Hello! This video will showcase GPU utilization from edge nodes in the EDGELESS platform from within virtualized environments. To achieve that, we will take advantage of the EDGELESS Python API and the container runtime. The goal is to assign the platform a workflow containing a skill function that must use a GPU for its computation. During this demo, we will establish a connection between two machines. On the left, we have the device on which we will deploy the core EDGELESS components, e-controller, e-orchestrator, and the CLI. On the right, we have an EDGELESS node with specialized hardware. Specifically, we have an NVIDIA Jetson AGX Orin board on which we will run the EDGELESS node code. This device will execute our function later on its CPU. On the Jetson, multiple panes are open to provide a broader view during the demonstration. First, we have Jetson Stats, a utility through which we'll ensure that functions can offload computation to the GPU. Then, we have Docker-related panes. On the left, we have the list of Docker images that exist on this device. On the right, we have the list of running containers. Both are updated in real time. In the next pane, we will run the EDGELESS node. The final pane will be used as a terminal to view file contents and run other commands. As we can see in the last pane, we are in the Python API folder. So we'll first ensure that from the functions developer's perspective, we have everything set to utilize GPUs by CUDA commands on our function. To make integration as simple as possible, we have provided some Docker images that can be used with a Python API and already include frameworks and libraries that leverage CUDA. The first step is to make sure that the Python API utilizes one of these images. Since we have that done, we are ready to develop our code. For this video, we'll just do a tensor multiplication using PyTorch, a well-known GPU-ready library. For convenience, we have created a new file that imports PyTorch, initializes two tensors in an initialization function, and applies the actual multiplication using a different one. These two functions can then be called in the appropriate callbacks in the function _servicer Python file to execute the actual multiplication. To be more specific, from the init and cast callbacks. As we can see, some extra log messages are also available. Now we have our function ready. Hence, we can build the function image. The image is now available to be used. We are ready to start the EDGELESS components. First, let's start e-controller, then e-orchestrator, and finally, let's run the EDGELESS node. From the log messages, we can make sure that the EDGELESS node has now been registered to the system and that it also supports container as a runtime. As we said, we will run only one workflow containing a single function in it. Let's examine the contents of this workflow. This workflow is going to run inside the container, and the code that is going to execute is coming from the python-function image. Let's assign this workflow from the CLI to the EDGELESS system. As we can see, a new container is now running on the Jetson device as we expected. Moreover, we will experience some GPU usage during the initialization. Remember that the actual multiplication is in the cast callback. To start the multiplication, we just need to invoke it. To do this, we can utilize EDGELESS CLI once again. The invoke command needs some arguments to run. First, invocation URL. Then node ID. then function ID. Finally, the payload. Before running that though, let's run first another command to view in the same time the log messages we added earlier to better understand the process. Now, let's invoke the cast callback and monitor the GPU usage to ensure that we can execute computations on GPU. Via the help of JSON stats, we can validate that the GPU usage is increased, which means that GPU executes our multiplication. For completeness, we will list the running workflows to ensure that the desired one is active. The final step is to stop the workflow we assigned earlier and verify that no other workflow is running in the background.